Hi everybody, welcome back to class again. We're doing another review here real quick. This is information that we're going to be needing going into our first lab here just so we understand how to measure all of these different things like length and mass, and then the next one will be volume. And again, this should even be a review for material that you learned back in 8th grade here. We're just pushing it further this year because physical science, which you would have had with me before, was a study of matter and energy, and chemistry, part of it is the study of matter. So you are seeing some concepts, and now we're finally taking them a step further. One of those concepts is mass. Now remember that mass is the measurement of the amount of matter in a substance or object. And we're going to go into more detail this year about what matter is, okay? But the base SI unit for mass is the kilogram. And remember, kilogram is this lowercase k, lowercase g, kilogram. That's the abbreviation for it right there. Now you're used to measuring mass or weight in pounds and ounces. We're no longer using any of these in class. Now we're going to be using milligrams, grams, kilogram. These are the three most common for you. These you will see the most often. And the most often of those will probably be right here with grams. That'll be the one that you see the most often. This will be what you see the most often. And I forgot to highlight these ones, but this should be in red, so you should be copying down each one of these things in your notes here. And I'll even highlight them in red for you. These ones here should be being copied down into your notes, even though they aren't in red here. But milligrams, grams, and kilograms. And you'll be able to see the difference in sizes of those as we go through class. Now, any SI prefix can be added to the root word grams. It can be added to the word grams for a unit of mass. So you could have something like a megagram, which is huge. It would be 1 million grams. You could have a microgram, which is really small. We're talking down to like a millionth of a gram now. You could have something like a nanogram, which is a billionth. Now we're talking down to the size of atoms. So when you change, you can add other prefixes to the word gram to give you another unit. But in general, milligrams are really small. Grams are small to medium mass, and kilograms can be from medium to large masses. Just to give you an idea, grams is about 1 gram is about the weight of a paperclip, the same mass as a paperclip. So to have a milligram, you would need to cut that same paperclip up into 1,000 different pieces. That's really small. The other thing is I wanted you to see is when we look here at this little nutrition fact, the nutritional square that you see on all the different things that you buy from the store, you will see mass used there. We have metric mass, we got grams, 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 milligrams, milligrams, grams, 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 grams. So you see grams a lot, you just don't even realize it or pay attention to it. And I just want you to be able to see that. There is still metric, English there, but it's not as common there on the back there because everything is going to be measured in the grams. So now measuring mass in this class, you're either going to be using a triple beam balance or an electronic scale, one or the other. Both of these are going to measure in the units grams. So both of these will measure in grams, and the lowercase g is your unit. Now, yes, you must include your unit. Remember, every single measurement that you do in class, every time you have a measurement, for example, 4.04 grams, you must have both a number and a unit. You have to have a number and a unit. If you do not, I would mark it wrong. The other thing you have to make sure that you have is your answer must have 2 decimal places. All the triple beam balances and almost all the scales that you'll use in this class measure 2 decimal places. So your answer's got to have 2 decimal places. An answer of 4.0 grams, I would take off points because you didn't include the other decimal place. Just so we're clear on that this time. I'm giving a little bit of leeway on the last worksheet with the length, but from this point going forward, we have to remember we need both 2 decimal places for mass and length, and you also are going to need to have a unit and a number, and make sure you have the proper number of decimal places with your number. But this picture here is just of a triple beam balance, which you should have seen before in my class. And you will be using them again this year. And this is just the different pieces of it. I will have a video of how to use the triple beam at another time. Now, measuring with the triple beam. When we're measuring with the triple beam, to find the total mass, if you remember, you've got to add all the beams together. So we have the 100-gram beam. We have the 10-gram beam. And we have the 1-gram beam. The reason the 100-gram beam is called the 100-gram beam is because it goes up in increments of 100. The 10-gram beam goes up in increments of 10. The 1-gram beam goes up in increments of 1. So when you're looking at this now, the 100-gram and 10-gram are easy to read. But when we get to this 1-gram beam, it should look familiar. It should look very familiar. It is the same looking image as a meter stick. Even though you are not measuring in meters, everything is measured in grams. This is 3 grams, 4 grams, 5 grams, 6 grams, 7 grams, 8 grams, 9 grams, 10 grams. Everything is measured in grams now, but it looks exactly the same. Even if we zoom in, this is 0.1 gram, 0.2 gram, 0.3 gram, 0.4 gram, 0.5 gram, 0.6 gram, 0.7 gram, 0.8 gram, 0.9 gram, and then it repeats, just like on a meter stick. And then in between here is your guesstimation. That's your guesstimation there. So it's going to be read the same exact way as a meter stick, so you don't have to learn anything new. And in this example, what we're going to do to get it all together is add them up. You'll read the masses. So we have 100 grams. We have 50 grams. And we have right here's where it becomes difficult to read, or more challenging than the other two, let's say. Just like a meter stick, this looks to be dead on there. So when it's dead on there like that, remember we need 2 decimal places. It's going to be 3.00. And we're measuring in grams with all of these. And this is read, again, exactly like a meter stick. So then all we do is add them up. 100 plus 50 is 150, plus 3.00 is 153.00 grams. Whoop. And there we go. Another example. Sometimes you're going to have beams that don't move, and they're just going to stay at 0. That's fine. We're going to read it the same way. We're going to add everything up. We can see this one is at 100, so we just have 100. And then we have to read the 1-gram beam. So it doesn't make it to 1 gram, so we're starting with that point there. We are starting with that point right here because it doesn't make it to the 1. And it looks to me, here's the 0.9 gram. It looks to me that it's slightly past that line, just barely. So I'm going to say 0.91 because it's slightly past and we need 2 decimal places. We need 2 decimal places. So when you add it up, 100 plus 0.91 gives you 100.91 grams. Again, number, unit. You must have both. And then, finally, on this last example here, you're going to have where you have 2 of the beams that are at 0. And that's fine. We're going to read it the same way again. We're going to jump right to the 1-gram beam, and we're going to see that the 1-gram beam is read, same as a meter stick, so we know it went past 4, but it doesn't look like it made it past a 0.1. So I'm going to read that as slightly before as 4.09 grams. Plus 0 gives me 4.09 grams. So this isn't going to be too difficult. This shouldn't be too outside the box or too new to you because, again, we're reading this beam the same as we did a meter stick. If you have any questions or any problems with this topic, please feel free to reach out to me. Thank you, everybody, and I hope you have a wonderful day.